So one of the most important quality of service measures is called network speed. And earlier during in this semester we talked about how to represent a network speed using different kinds of units, base units. So we know the network speed is measured in bits per second, or bps, but these numbers sometimes they get really big, so that's why we use this thing called metric prefix. And for example, if you have million bits per second, instead of writing down 6 zeros there to represent the network speed, we simply use this capital M to represent million. So that's called metric prefix, and then say bps. So if we say 1 megabit per second, that's equivalent to 1 million 6 zeros bits per second. So as you can see, by using these metric prefixes, you can really abbreviate the network speed representation, make it much easier to write down and also communicate with. So we have, for example, if we're talking about 1000 bits per second, that was 1 kilobit per second, and that's 1000. bps. And we also talked about 1 billion bits per second, that's 1 gigabit per second. So in this case you have 9 zeros. And finally, these days, I mean, we are now starting to talk about terabit per second, so that's actually 12 zeros. So as you can see, it's much easier to write 1 terabit per second using the metric prefix instead of writing 12 zeros. That's one of the reasons why we use these metric prefixes. So one question that arises when we talk about network speeds is how to write them down properly, because there are so many different ways of writing them down, since we have all these different types of metric prefixes and these choices. So that's something we're going to talk about in our next slide. So how to properly write network speeds. So how to properly write network speeds. So rule of thumb I can give you is that you always want to have 1, 2, 3 places before a decimal. If this is not the case, then something's not right. So let me give you some examples. So let's say you have network speed that says 0.321 or something like that megabit per second. So if you count the number of digits before this decimal, you have none, because we don't really count 0 as a digit in this case. So this is actually not a proper way of writing this number down. So you can actually rewrite this number 0.321, since we have this metric prefix million, right? So if we change that metric prefix million into kilobit per second, actually this is equivalent to 0.321 times, let me see, times 1000 kilobit per second, because what we just did was, by changing metric prefix million to kilobit per second, so from going from million to kilo, what we did was basically we took 1000 out of million, or megabit per second, and then we changed that metric prefix to kilo. So you can rewrite this as, now if you multiply 1000 to 0.321, it becomes 321 kilobit per second. So as you can see, this is equivalent to 0.0, like that, right? So before the decimal we have 3 places, so which is correct. So usually we don't write down 0.0 this way, so that's why we leave that out, and that's why we end up with 321 kilobit per second. So pay attention to the fact that by changing this metric prefix from million to kilo, you can take this 1000 out of that mega metric prefix, and then by doing that, by dividing this mega or million by 1000, we're actually left with only 1000, right? So that is kilobit per second. So I can rewrite this just to help your understanding, something like this. So when I started, I could have started 0.321, since million is 6 zeros, 1 million, like this, right? That's actually bit per second, like this. And as you can see, we can take 1000 out of million, like that, right? And we could have said 0.321 multiplied by 1000 multiplied by another 1000, right? That is the same thing, right? So another 1000 there. And in this case, what we did was we kept 0.321 multiplied by 1000, but we turned this 1000, this 1000 here, we turned this into basically kilo, right? Because kilo is 1000. So that's why we came up with this number here, 0.321 multiplied by 1000. So if you simply do the computation, you end up with 321, and you still have kilobit per second, and that's why we came up with that number. So this is how you can break it down. Another example could be something like this: 5,000, let's say, kilobit per second. Okay, so again, we can rewrite this. What's the problem with this? You can rewrite this as this, right? It's the same thing. And as you can see, before the decimal you have 1, 2, 3, 4 digits. So in this case, you have too many digits before the decimal, so we somehow want to get rid of some of the zeros, and you can rewrite this by saying 5.0 multiplied by 1000, that's 5000, correct? Right? And another thing you can do is kilobit per second is, kilo is another 1000, right? So you can say 1000 and bit per second like this. So how many? So 1000 multiplied by 1000, that gives you 1 million. So basically you can say the same thing as 5.0, and that's 1 million, right? These together is 1 million. So 5.0, 1 million is mega, right? Megabit per second. So you can rewrite the whole thing as 5 megabit per second. One thing you want to pay attention to here is we always have this space between the unit and the number itself. So 5.0, but we have space and then the unit. That's how you write. Another thing I want to point out here is, unlike all these other metric prefixes out there, we use lowercase k for kilobit per second because the capital K is already being used in physics. Capital K is used to represent temperatures, Kelvin. Okay, so that's why we use lowercase to represent network speeds here. Okay, so that's something you want to remember. Now let's talk about the difference between rated and rated speed and throughput. So rated speed is network speed advertised by, so network speed advertised by the vendors. So these are just claims, and these are the speeds that are potentials. So what you usually see when you get your network service isn't always matching what the vendors claim, because there are so many different factors that decide your network speed. So the actual network speed you're getting out of your network is called throughput. Okay, so the throughput is the actual speed. The throughput can be also categorized into two different types. One is aggregated, and the other is individual. So aggregated means the network speed you're talking about is the combined speed of your network, and typically a network has many different users. So if you have a line that comes to your entire network, that is, let's say 1 gigabit per second, but if you are sharing that line with multiple individuals, let's say 10 people or something like that, then the individual network speed isn't really matching 1 gigabit per second, right? So that's going to be 1/10 of the 1 gigabit per second. So that's called individual throughput. The actual network speed these individual people are getting out of that single line.